The main event you've all been waiting for, the algorithm finals, is here. It has just begun. So let's go check in with Errichto and Lewin with all the details. Take it away.
Hi everybody. We are here at Topcoder Open 2020 finals. After two semifinals, we have now 9 finalists. I'm Errichto. Hi Lewin.
Hello.
We will discuss the contest. It will be 85 minutes long, then short intermission and challenge phase when participants can see each other's code and they can try to find a counter test to gain some extra points. Already something is going on in the leaderboard, so we can start from that. There are 3 problems worth today. Lewin, do you know the points?
Yeah, so today's problems are for the easy, it's 400, for the medium, it's 450, and the hard is 1000. So this suggests like the easy and medium are pretty close in difficulty, but the harder is still hard, of course. So we'll see if that changes any of the strategies for the contestants on like how they choose the ordering of problems that they open.
We can already give you some details from behind the scenes. There wasn't an agreement on the comparison of difficulty of first 2 problems, easy and medium, so that 400 and 450, it could as well be kind of twice that in either direction.
Yeah, that's true. It was hard to decide on the points, I think. So like this was a good compromise. Some people thought the medium was easier than the easy, or vice versa. So like this making them pretty close in value seems like a good compromise.
Yep. They are 2 very different styles of a problem. We'll see the statements later. Almost everybody started from easy. The default strategy for most people is easy, medium, hard. Umnik instead opened the 450, so medium problem. And the white points in the leaderboard, they decrease because they denote if a participant finishes solving this problem right now and submits their code, this would be their score for this problem. The faster you submit, the more points you have. Right now, Umnik would get 443 points for submitting.
Yes, that's true. Yeah, so it depends on how long you take to submit. And of course, this is still a very optimistic scoreboard. So even after you submit, there's a possibility you can fail during the challenge or system test phase. So these points aren't finalized even at the end of this round. Exactly. Or at this phase.
As we said earlier, there are 9 finalists. Most of them are from USA and Russia, at least originally from Russia. Right now, everybody has 0 points, so it's not that we go really from the top. But looking from the top, we have 7K plus from China, then Petr from Russia, or right now Switzerland, Umnik, Kalinin, all from Russia, Yegor right now representing Germany, then Tourist, by many thought to be the strongest competitive programmer right now.
Yes, he is the favorite.
Yep, and 3 participants from USA, Neil, Scott, and Andrew, or Eknerwall. Among the USA contestants, who do you think is the strongest?
I think Andrew is probably the strongest. But I mean, they're all very strong. So it's kind of hard to tell because like as for finals, I think there's a lot of variance. So like really it is kind of anybody's game. Yeah, but I think Andrew has pretty consistent performances on like regular online contests. So we'll see how well he does in this one.
Yep. This is Eknerwalla's screen, so Andrew's. He's solving the easy problem worth 400 points, and we see on the screen those 2 magical characters, DP, dynamic programming.
Yes. I mean, it's hard to tell if he's on the right track because this problem is definitely a DP problem. But we'll see how he codes. He might just be coding some boilerplate for now. Yeah, it looks like he stopped for now just to think a bit more, but he might continue typing.
I belonged to people who think that this easy problem is very easy, but it might be just because I solved many dynamic programming problems in my life.
Yeah, that's true. Yeah, the easy problem is Yeah, it is a DP problem. So if you're strong with dynamic programming, this is definitely a better problem. The medium is more about game theory. So if you're stronger with game theory, then that might be an easier problem. We'll see the statements a bit later in the stream, but just kind of giving a brief hint out, like what the topics those two problems cover.
Did we have the same for one of the semifinals, or maybe both? At least once, dynamic programming was the first problem, and then I think game theory was the last. In Rainbow Nim, your problem.
Oh, right. Yeah, the semifinal too. Yeah, we had a dynamic programming with the caterpillar spanning trees. Yeah, so I guess now let's move on to talk about the 400-point problem, BFS order. So in this problem, you're given, so you can define the algorithm BFS or lexicographic BFS, where you basically have a queue of vertices. You initially put 0 on the queue, and then for each vertex, when you pop it off the queue, you add its neighbors in increasing order into the queue. And then basically at the end, you have some permutation of the nodes based on the order that they were put into the queue. So in this case, given this graph, we can kind of compute the BFS ordering. So we start at 0. And then
I will go through this example.
Okay.
We start, the statement says you need to start from 0, and always when you have some neighbors of a vertex, we start from 0, you go for them in increasing order. 0 has 2 neighbors, 1 and 3. So in this order, we add them to a queue. Then the next vertex to process is 1. You can imagine that 0 is removed from a queue, but it doesn't matter that much. We can as well just leave it. Now looking at 1, we need to process neighbors of 1. Those are 2 and 5. So we then push 2 and 5 to a queue. The next node to process is 3. 3 has neighbors 4 and 5. In this order, we need to add it, but 5 is already added, so it's 4. And then if, let's say, 2 has extra neighbor 7, well, it would be then here, because then we would consider neighbors of 2. But if the black graph is everything we have in the, if this is the graph given to the BFS, lexicographical BFS, this is the order we get at the end. All right, what do we need to compute?
Yeah, so in this problem, you're given a permutation on 0 through n minus 1, and you would like to compute the number of graphs where BFS order will give this permutation.
Yep. Given this in the input, you need to count how many graphs, and the total number of graphs on n vertices is 2 to if power, where e is the number of possible edges. So like 2 to n times n minus 1 choose over 2. Like,
yes.
Choose 2. So among that many, how many of them will give us this permutation? And those graphs, they need to be connected.
Oh, so we've seen 2 submissions, one for the medium, one for easy. So yeah, it looks like, I mean, both of these problems are about the same level of difficulty, so we would expect to see them solved at around the same amount of time. But we'll see how long they spend on testing before moving on to the other problem.
Here, this easy was solved faster because Jaeger just lost 25 points, Umnik lost 39 out of a bit bigger number, but still, it's kind of proportional.
Yeah, and we see Kalinin also submitting the easy. So we might see other submissions coming in soon. It looks like Umnik actually opened the hard right now. Yeah, so he just opened the hard rather than easy.
Umnik is known for just solving problems.
Yes. Yeah. I mean, I don't know if this is like necessarily a good strategy, but I mean, he knows the easy is not too hard, so maybe he just wants to make sure he has enough time for the hard and he can switch to the easy in the last couple of minutes because he knows like the easy is not impossible. So this seems like a good strategy for now.
In a moment, maybe we'll switch to screens of a few participants like Yegor, Kalinin, and Tourist. The first 2 likely are now testing easy, but maybe before that, we can talk about a solution quickly.
Yeah, so actually for bounds for this problem, n is up to 3,000, I think, right? And then you
Yes.
return this mod some number like mod 10 to the 9 plus 7.
You're given a permutation like this red one of size n up to 3000. And you need to print a discount. By the way, this is not correct answer for this permutation. This was just kind of an arbitrary value, but you need to return one integer. All right, and yeah, n up to a few thousand screams dynamic programming. It's very common if constraints are low.
Yeah. Yeah, so we can talk about how to approach this. So yeah, I guess the first step to start is you're just given arbitrary permutation. The labels do matter. So like, yeah, I guess we can write this down. So the first step might be, you can think about how BFS processes the vertices, and it processes the vertices in increasing order of distance from the start node, right?
Yeah.
So like initially there's the first node is like where you start that has distance 0. But then you have some contiguous intervals where it's just like the next certain subset or certain interval is like distance 1, the next one is distance 2, and so on.
Yeah. So I marked here for every vertex what new vertices it adds, and indeed we have some kind of layers here because there is 0, then there are 1 and 3, and then there are 2, 5, 4. It's more visible here because the layers are just 0, 1, 3, and 2, 5, 4. The layers by distance from the start. Yep.
Yes. Yeah. So this suggests some sort of DP approach where you go layer by layer. So I guess we're looking at some screens.
Screen?
Yeah, Jaeger's screen.
Oh, he already... No, he's testing, right?
Yeah, he has already submitted. He was the first one to submit the easy. Looks like he's just testing more.
Yep. He needs to iterate over all possible graphs and run this BFS, count stuff. Just be certain that your solution is correct.
Yes.
The leaderboard suggests that you should test because both problems in medium were solved very fast. So we will have enough time to solve everything. And then it's better after every problem to check that you solved it correctly.
Yes. Yeah. And it also looks like Petter has resubmitted actually the easy. So he submitted twice. So you do get a penalty for submitting again. So you might have found a bug.
Interesting. That might be an overflow, or in edge case like n equal to 1 or 2.
Yeah.
All right. Yep. Then back to our solution. Yeah, there are layers, and the initial intended solution for this problem was supposed to have complexity n cubic, and indeed it went through layers of this. It was more or less this. If right now you're at some node and you're processing its neighbors, you want to consider what will be its neighbors, and then this is the last layer thing, or actually, well, then the whole layer is down. But that solution tried to do layer by layer. And for every next layer, if there is some increasing part, we know that it could be neighbors of some previous node.
Yes, so it's mainly about deciding how to arrange the edges between layers. So you do also need to consider edges within the same layer, right? But that one is much easier to compute. It's just like you can, like, it doesn't really matter what edges are present there. So it's like 2 to the number of, or like 2 to the n choose 2.
If we look at a layer like this one, 2, 5, 4, then there are 3 possible edges here, and you can choose any of them. It doesn't mess up the whole order. So you need to multiply the number of ways by 2 to the third power. But also you can get some unnecessary edges between 2 consecutive layers. That's more tricky.
Yeah. So with those edges, you need to be careful to make sure that the permutation is still the one that you get, right? Because you always add like the lowest index neighbor that you see, right?
Yes. We will maybe analyze the leaderboard because before we finish talking about this problem, because we will miss a lot of submissions.
Yes. Yeah, we have a lot of submissions.
6 submissions for easy, and all of them Eknerwal being the last one seconds ago, opened the medium problem.
Yeah, so only Tourist and Neil still working on the easy, but they're still ahead of Petter at least because Petter had to resubmit.
We can maybe take a look at Tourist screen to see if he's close. And he's switching between the editor. Oh yeah, compiling,
Yeah,
and we'll see a submit.
yeah, he's compiling. Okay, yeah, he just submitted.
Cool.
And maybe we can see how Neil is doing as well, if Neil is close.
Yep. Let's see Neil's screen and then back to the leaderboard. It was nice to catch Tourist submitting a problem.
And he's still testing a lot of the examples, just making sure. Okay. Yeah, so we're looking at calendars. Yeah, so he's just reading the medium problem now.
He is the third among people who solved easy, but still behind Umnik. Umnik was the first to solve medium because he went for that one, and Umnik is right now doing the hard problem.
Yes, and Umnik did solve the medium pretty quickly, so we'll see if other people can match his speed on this problem.
Okay. Neil is looking at statement of the first problem, BFS order, and I don't see if he implemented anything. On the left, there is a lot of pre-written functions like power, modulo, prime.
Yeah, these look like just a template for like the modular arithmetic, so it doesn't look like he has any of the DP down yet.
And that's a bad sign because this is a relatively easy problem. He's looking at the leaderboard right now, maybe considering switching to another problem.
Yeah.
If we look at the leaderboard, I can say something about an interesting bet going on. There is a bet between kind of USA and the rest of the world, or part of the rest of the world. And it's about the sum of places taken by Scott, Eknerwal, and Neil, the three participants from USA, versus four people from kind of Russia, Umnik, Yegor, Tourist, and Petr. Those Umnik, Yegor, Tourist, and Petr team, they are more experienced, at least on average, but there are more of them. So, the sum of places will likely be bigger. And then that kind of evens out with their experience. And I'm on the Russian side of this bet.
And I'm on the US side. We'll see if Neil can solve the easy. But the number of points he can get from it is actually approaching Petter's points. So he might switch to the medium because it might not be worth that much in a few minutes.
Also, Tourist finished testing easy. And this is Piotr's screen.
And it looks like he's just writing a brute force for the medium, it looks like. Oh, it's kind of hard to tell exactly, but it looks more like a brute force. So he might just be trying to find a pattern with the medium and seeing if he can solve it from there.
A lot of people start game theory problems like that.
So actually for the medium, I don't know if it helps that much to write the brute force. Like you do need to understand kind of how it comes up. I mean, we can talk about it, I guess, when we discuss the problem then.
Yep. All right, then let's finish the easy problem. And regarding question from the chat about us missing Kalinin, we couldn't really do 3 versus 5. Well,
3 versus 5.
It's 3 versus 4, but the 4 are very, very experienced. And right now, the USA is 18, and somebody counted Russia without tourists, so it's 11. They said that adding Kalinin to the USA side to make it 4v4. Okay, but I will finish first. Solution to this problem. This BFS algorithm, instead of thinking about layers, we can just say, as I drew here with colors, the fact that some node, it adds an interval of vertices. And indeed, if I can call it a state. What is important is that up to here, everything was already added to a queue, and the fact that I'm looking at this node right now. So the DP is just DP of ij, where I denotes my current node from which I'm adding neighbors, and j means that everything up to j was already added. And this just means if there is that sequence from the input, and I is here, j is there, it just means that there is some kind of graph, and everything up to j is already added, and it is connected with each other, maybe with some more edges. That's possible. And a moment ago, I'm done adding vertices from I to its neighbors. Then I will see this guy I plus 1, and I can add some interval, assuming that it's increasing.
Okay. Yeah, that makes sense.
And transitions will be from dpij to I plus 1 and something, to I plus 1 and k, such that k is greater than j, and everything from j to k in the input must increase.
Okay, yeah. And you can like pre-compute some of this, I guess, right?
Yeah, you can pre-compute the intervals that increase. But this just means that this next guy, you want to connect it to something on the right. And additionally, it's okay to put edges to those because those are already connected, and it doesn't matter. So you will multiply by 2 to power of j minus I think minus or plus 1. So dp of this multiplied by that is added to dp of I plus 1k. And yeah, the remaining trick is that we have some interval for k, how long we can do increasing, so we should use prefix sums to add dp value to interval of dp values. Then instead of linear transitions like that to iterate over k, you have just constant time. Whole thing becomes n squared.
Yeah, and that makes sense.
And code is just short.
Yeah, Neil is still having trouble with the easy, and he might still want to just work on it. I mean, nobody else has solved the medium other than Nick, but none of them has had it open for as long, except for like Petter and
regarding the bet, Tourist and Petr are not doing well either, with worst times on easy, and 2 participants at the bottom of the leaderboard will do more than 1 participant at the bottom. But obviously, hard is the most important problem today. Easy plus medium will decide about people who don't really solve hard.
Yeah, I think Neil's strategy might be like after he solves easy, just open the hard and see if he can do it, or if he just wants to like minimize place. I mean that will like help him minimize like I guess expected value if he wins. But if he wants to minimize place, he might open the medium, depending on how many people solve it by the time he solves it easy.
7k plus here, implementing the second problem. Is that a brute force? That's the main question.
This does not look like the brute force. It looks like it is close to the intended solution. So we might see a submission from him soon.
Yep, that looks about right. He doesn't call the same function recursively.
Yeah. So maybe we can talk about the medium problem now.
We should.
Yeah.
This was the one with 5 piles, right?
Yes, this is the one of 5 piles. So in this problem, it's a modification on the NIM game. So it's another game theory game. So you're given 5 piles of stones. Each pile can contain up to, I think, 10 to the 18 stones. So it's a very, very large number. So in this problem, the moves are you take some piles from stones. So there are a few options. The first is you can take any number of stones from a single pile. This is just like normal NIM. Another move that you can make is choose 3 consecutive piles and remove the same number of stones from each pile. So in this case, we took 2 from 3 consecutive piles. And the last type of move you can make is choose 5, like all 5 piles, and choose and remove the same number of stones from each pile.
Yep. 1, 2, or basically up to minimum of the 5 piles.
Yeah.
You cannot go below 0 anywhere.
Yeah, so the piles still remain even if they're empty. So if, like, for example, the second pile was empty, you can't do a move of the last type.
Yeah. Here, new sequence is 1, 0, 3, 2, 1. And it basically means that we have 2 independent problems, the 1 and 3 to 1. You cannot do anything
Yeah,
both
you
at the same time.
You can't choose like the first 3 piles in this case because the second pile is empty. So you still need to remove a positive number of stones. And in this case, the problem is not to determine who wins or not. It's just to determine the set of all winning moves and return like the set of all winning moves.
Yep. Somebody said, I'm guessing the author of this problem is Lewin.
No, I did not write this problem, but it is the type of problem I would write.
It's also kind of, it would be strange to suggest 2 related problems to the same tournament, to the same competition.
2 game theory problems are the same. But I think the author of this is Misov, so Misov wrote this problem. So usually in problems like this, the first step is, of course, determine the set of winning and losing moves and determine who wins or loses. So it's kind of like the semifinal 2 hard problem where you determine like the numbers for each pile.
Ekner-Wallace solved both easy and medium, and he's winning right
so
now.
he just submitted the medium, and he moved on pretty quickly to the hard afterwards. So he might be pretty confident in the medium.
Yeah, it's a strange move to open hard immediately. In medium, you can still mess up, unless maybe he already earlier tested it a little bit. We can take a look at his screen if some testing is running, or maybe he's just looking at statement for hard.
Yeah.
400, the first problem was the dynamic programming one, then 450 is this one we are talking about now, 5 piles related to game theory. And 1000 is a hard problem about just observations, something that sequences, period of modifying sequences, just your hard problem about observations.
Yeah, the hard problem is pretty hard. It took me a very long time to solve it. Like I did test it out. But yeah, I think it is possible. We'll see some solves. I think it is doable.
He's already implementing something, but I'm betting it's just a brute force.
Probably just a brute force. Because I think it is really about finding patterns in this problem. And once you find the pattern, it is still like not that much afterwards to solve it. So the problem is just convincing yourself the pattern works and like making sure you cover some edge cases.
So Ekner-Wallace has easy plus medium, and he opened hard just minutes ago. Umnik has medium, and he's working on hard for quite a long time already. And it will be interesting to see if he has something, if he started coding. And if not, eventually he will need to switch to easy.
It looks like he wrote... he did write a brute force, and he's looking at some patterns, so he's trying to look at which... it looks like he might be on the right track, because you do eventually want to look at sequences that are just ones and zeros. It looks like he's just drinking some water. It's pretty important.
That's some professional microphone setup.
Yeah, it's a very nice microphone.
I should get such a stand. I don't know a solution for hard, but I also read that there is something there about binary sequences at the end.
Mm-hmm. He might be trying to... I don't know what exactly his approach is, but we can talk about the hard when we get to it later in the stream.
Already 3 people with easy plus medium, 7 Eknerwal, Tourist, and 7K plus with this order from the top. And USA takes the lead in the bet of USA versus not full Russia. Eknerwala is doing very well right now. In particular, if hard turns out extremely difficult and there are no changes just in the leaderboard, then Eknerwala has won the whole competition.
Yes,
But
that's true.
somebody might solve hard
Yeah,
problem.
somebody might solve the hard, but we'll see, I guess. The hard is the type of problem where you can solve it, like where it's very easy to test like the max cases, and you can test locally as well a lot. So
Yegor is still looking at outputs, I think.
yeah, it looks like he wrote a brute force.
Iterated over all states, and he just, for particular values of, let's say, first, second, and third pile, you can print what happens depending on the last two piles.
Yeah,
And
so,
I think you can get the winning conditions this way, because winning condition is easy.
Yeah, the winning condition is pretty, or like the pattern should be easy to see, I think. But I don't think it'll help that much because it is something that like you'll still need to like use effectively to find the winning names.
I think that, well, I would say that right now Umnik is looking strongest in terms of easy and medium, because he has best time in medium, and in easy, everybody above him, so the whole top three, they don't have really that good time. Yegor, Scott, and Kalinin, they solved easy faster than Eknerwal, Tourist, and 7K+. It's easy to
Yes,
beat
that's
them.
true. So yeah, if the hard does turn out to be unsolvable, I think Nick has the best position right now because he has the potential to solve the
He needs
easy very fast.
330 points to beat Eknerwal.
Yeah, and that is fairly doable because a lot of contestants have more than 300.
That would be right now 6th best time.
Yeah.
Then
Yeah,
it
but it
will
looks
be
like 4 people
interesting.
have opened the hard, so we might see somebody solve the hard in the remaining 50 minutes. We still have a lot of time left in the competition.
Should we solve the 5 piles problem?
Yeah, we can go back to 5 tiles. Yeah, so in this problem, like the first step, of course, is like classify which states are winning or losing. Yeah, so I think what you get from like brute force or pattern matching is that the state of winning or the set of winning and losing positions is exactly the same as normal NIM. So like it doesn't matter that you can remove, like these extra moves don't really affect it that much. So in normal NIM, like you take the XOR of the 5 piles and it's winning if and only if the XOR of these piles is not zero. And yeah, I mean, basically the way you can see that is if the XOR is not zero, there exists some move that you can do to some pile, which makes the XOR zero. Otherwise, if it's zero and you make a move, it's going to change it to be non-zero. And then like once you can make no moves at all, if all piles are empty, the XOR is zero. So that's losing. That's losing.
Maybe a useful hint how to get this idea that it's just the same winning states as the standard game is that the number of piles you touch is odd.
Yeah. So
That's
actually, for this problem,
1, 3, or 5.
yeah, if you change the condition so that you can remove the same number of stones from an odd number of piles from any subset, the problem would still be about the same, I think, or like it wouldn't change that much in difficulty.
I wouldn't be surprised. Yeah.
Yeah. So this might be actually easier to think about because only the oddness of the number of piles you touch matters, like not that they're consecutive or not. Yeah.
Okay, and the proof is very related to the solution itself, right?
Yeah. So basically, the way you can see that is, let's say you remove X stones from each pile that you touch. So in this case, X is 2. If you look at the lowest bit of lowest set bit of X, you'll notice that this flips the XOR of the lowest bit.
Yeah. So in number 3, 3 is 1, 1. Then 2 is 1, 0. 5 is 1, 0, 1. Oh, people will not see what I'm typing. Let me move that. Then we have what? 4.
is 100.
and 3. Okay.
Yeah.
So yeah, if it doesn't matter that it's actually -2, the 2 is here. It's important that it's lowest bit in the difference in our move. Then in this column, every bit will be flipped. If you have a set of binary numbers and from each of them you decrease it by, let's say, 1, 0, 1, 0, that's what, 10, 2 plus 8, then it will flip each of those bits.
Yes.
Because it will not touch the suffix, but it will touch this one.
Yeah. So we flip the lowest bit, and the lowest bit, since we touch an odd number of tiles, the lowest bit is flipped an odd number of times. So this necessarily changes it. And basically, you can repeat this logic recursively, kind of. So like you ignore all the lower order bits, and then you move.
Quick update. Petr solved now easy plus medium, and he has the 4th place. Okay, we're back with solution just immediately, I guess.
Yeah, so seeing a lot of submissions. So back to the solution. If we flip the lowest bit, if we'll always flip the lowest bit. So if we iterate from lowest bit to highest bit, determining which bits we need to flip, we'll get a unique X. So once we choose some subset of tiles to remove from, there's only one X that works that could be winning.
Mm-hmm. We choose its bits from the right.
So there are some conditions you need to check. You need to make sure, for example, the number of stones you remove isn't bigger than any of the tile sizes, and so on. So once you iterate from lowest to highest, you can determine what the value of X needs to be if you were to remove from some that particular subset of tiles.
If the XOR of some bits is already 0, then you don't want to touch that. If the XOR was 1, then you want to modify it. So you say that when you keep choosing bits of your X, then that was 0. That was 0. Then here you have 1. But if you already know that you'll decrease everything by 2, you can as well just update all those values. It will modify the prefixes. And then just continue your process. In this column, check the parity. Maybe you will detect, the parity is good, it's even, don't touch it, and continue doing so. Whenever you have 1, it means subtracting something, so update the 5 values, or 3 values if you only touch 3 values, and continue.
Mm-hmm. Yeah, that's right.
And you just consider the 5 single moves plus 3 triple moves plus 1 5 type move. And that's 9 moves to consider for each of them. You just try to construct this X from lowest bits.
Mm-hmm. Yeah, and it looks like Scott has submitted the medium problem as well. So he jumps to 4th place a little better.
Yep. And still Umnik is looking strong because of his good time in medium.
Yeah, and the hard looks like he has spent around half an hour on the hard, I would say, right now. He did open it immediately after the medium, and that was around 110 or 120, I think. So
we'll see now Neil's screen. He jumped from easy to medium.
Yeah, looks like he gave up on the easy because it isn't worth that much.
It's a good choice after some time to switch. He can be high with medium plus hard.
Yes, yeah, and it looks like he's writing the brute force for the medium. I would say the brute force, as I mentioned earlier, does not help too much with this problem because even if you do know the winning conditions, since the pile sizes are up to 10 to the 18, it's not feasible to iterate through all moves. You need to be able to construct the moves efficiently, as we mentioned, going from lowest bit to highest bit.
Information about the XOR being equal to 0, it tells you, okay, I need to make XOR equal to 0, and then you can start thinking about that, how to decrease, let's say, everything by X to care about XOR of everything. So it means, okay, if the XOR of everything is odd, my X needs to have 1 in the last position.
Mm-hmm. Yeah,
that might help.
Yeah, so that might help a little bit. Yeah, this is. I don't think this is Neil's screen. He's just Russian. I know that this is Neil's screen. This is Peter's screen. So it looks like he is. Well, it's hard to tell. He's working on the hard right now, and he's coding something.
If he wants a set or a map, then is that a brute force?
Well, it's hard to tell. I'm not sure.
He creates a map. If he creates a map, then it might be just a brute force to say when you got this sequence in which turn.
Yes, it looks like it probably is a brute force. So he's generating all arrays of a certain length with elements between 0 and 10, it looks like, and then running the brute force on it, and then seeing where it goes. So maybe you can talk about what the hard is. Just go over the problem.
I guess we have a lot of time for that, so maybe in 5 to 10 minutes we will now just go calmly through.
Another update on Leaderboard. Yegor has solved the medium, so he jumps to 5th, going above Petter now. So it looks like a lot of people have easy and medium. And it looks like we'll see if the hard might be like really the tiebreaker then, or like the decider of this match.
Here, almost everybody is within 60 points from each other on easy, and then in medium the differences are bigger. So right now, people are mostly sorted by their performance in medium problem, 450.
Yes, yeah. So I actually don't know if there's that many tricky challenge cases. I don't know if how strong the samples were. So I'm not sure if there will be any available challenges. So during the challenge phase, you can look at a competitor's code, and if you can find a test case where their code is incorrect or times out or has some other error, you'll get 50 points. So it is pretty close because a lot of these people are within the 50 point or 50 to 60 points. Mm-hmm. So the leaderboard can change a lot during the challenge phase.
Tourist is just trying to find a pattern as well.
Yes. Looks like he's just trying to find the pattern for it. Yeah, for the hard, I think you don't actually... Well, I guess we can talk about it when we go over the problem.
We can maybe say what the statement is about.
Yeah, we can talk about the statement. It looks like Umnik has actually submitted the 1000.
Oh, and his screen will be more interesting now than the statement for hard. Will he continue his strategy of just jumping to another problem, or maybe it's time to test?
He has opened the easy problem now.
He just jumped to easy, no testing. Or you could also test before.
Yeah, you can test locally. The hard is a problem where you can test the max case locally pretty easily and on the arena as well.
So then you shouldn't worry about speed, and it's just about some edge cases like n equal to 1. Mm-hmm. But Umnik hasn't won yet because maybe he has a mistake in one of his codes, and also other people started hard later, so they can still got many more points. Kalinin is one more person to solve medium, so Umnik has medium plus hard. Neil recently switched from easy to medium, and everybody else is just easy plus medium.
Mm-hmm. Yeah, so it looks like the winner will probably have all 3 problems solved, at least. Or it looks like it's trending that way, because we do have submissions on all 3 problems already.
And we have 40 minutes left. I would say that top 3 will have easy, medium, and hard.
Yeah, that does seem pretty likely, the way this is going.
We have obviously very strong participants in the finals. To be honest, I hoped for maybe some almost ties on easy plus medium, because then range of scores was very small, so any challenge plus 50 points could change a lot. And so many people will work very hard during the challenge phase to fight for the first place. If they all solve hards, then the distribution of points will be very wide, like somebody with 1,300 points, somebody maybe with 800, and then you don't need to challenge because you will not gain a place.
Yes, that's true. Yeah, I think the range of times for hard can be pretty large, so depends on how fast you can find the patterns and stuff.
Umnik still looking at the statement of easy. Will he start coding in a minute or 5 minutes, 10 minutes? I wonder.
Yeah, he has had it open for like a couple minutes so far. So he's still just reading statement, probably just thinking now.
I hope it, and it will be good for him, that he opened as a standings leaderboards and he sees that this problem is easy, that other people solved it very fast. You shouldn't, during a contest, just open every next problem and try to solve it. You should use the leaderboard as a hint. The leaderboard showing you that other people solved it in 5 minutes, it means something. It means that you shouldn't think about anything complicated.
Yeah, it means that the approach is relatively easy to code and maybe easy to think about. So he doesn't need to think too hard about like different techniques to solve this.
But chat saying that Umnik is so strong, but at least he didn't solve it. He didn't solve everything in half the time, because the contest is 85 minutes and it's now 50 minutes from the start.
Yeah.
It took him more than half the contest for sure to do easy, medium, hard.
Yeah. And now we're looking at Kalinen's screen. He's just reading the hard, looking at samples. Yeah, so maybe we can talk about the hard a bit while we wait. We might see a submission from Nick soon, though, so we'll see.
From time to time, we'll check the screen of Umnik to see if he's coding already.
Make sure he's not close, or like whether he's close or not. Yeah, so moving on to the hard, and go over the statement. So
I don't remember the title. What was it?
Different sequence.
How? What?
Different sequence.
Different. Okay.
Difference. So yeah. So basically, for this problem, you're given some sequence of editors of length n. You can define the difference sequence of this to be the absolute values between adjacent elements. So, for example, in this case, you would get two. The sequence is circular, so basically you take the difference of the first and last one as the last element. So in this case, it's 2, 1, 3, 0.
Yep. I took the difference between every two consecutive elements, and then we repeat that.
Yeah. So basically, we repeat this process, and you can prove that eventually that this will get into a cycle. In this case, I don't know how long this cycle is, but
this turned out to be very easy.
Yeah, then it's 0, and once you get 0, 0, 0, 0, you'll just continue to get 0. So basically, we can say given a starting sequence, you can repeat this process until you find a cycle, and then the representative of the cycle is the lexicographically largest element of the cycle. So maybe you can go through an example where the cycle is length more than 1. So for example,
you have the statement open?
I remember for length 3, if you start at 0, 1, 2, I think, or not 0, 1, 2. Let me open it up real quick just to make sure.
And while that happens, Umnik has started coding. We'll see his screen.
Okay, we'll see if he gets close. Okay, so in okay, it looks like
I
he's
see powers of 2.
Yeah, powers of 2 is a good
nothing
sign.
more so far.
A, I'm not sure what A means, but
maybe it's a helper array for BFS order. Would be strange, but maybe he just wants everything in arrays. I can understand that some people will just first grab all the arguments from a function and put that in global arrays because this is what they would use in code farces. It isn't important to do. you might prefer it that way.
Yeah.
All right. He isn't that fast here. That's good for other participants.
Yeah.
dp of n, and 2. I also got an idea for second dimension. I mean, third
Or third
dimension being
dimension.
0, 1. To say if you still continue adding neighbors to the most recent node, then you don't need to do prefix sums, I believe. You do prefix
I
sums,
see.
or you do this one extra dimension, 0 or 1.
Like whether you're continuing the previous element or not.
Yes,
Or like
exactly.
extending the previous.
And then only if you continue, then you can add the next element if it's greater than the previous one. And if you don't continue, it just means you jump to the next element.
Yeah, that makes sense. Okay.
Right. Statement. Yeah. Example for this difference
Example.
sequence.
So the example in the statement is 2, 1, 0.
All right. 2, 1, and 0. Then differences will be 1, 1, and 2. Is that right?
Yeah, 1, 1, 2. Then 0, 1, 1. Then 1, 0, 1.
1, 0, 1.
Then 1, 1, 0.
0. Still no cycle.
And then 1, 1, 0. Then 0, 1, 1.
All right. Like this. And we care about the lexicographically greatest
element of the cycle. Yeah, so in this case, it's 1, 1, 0.
Among the cycle, we care about the lexicographically greatest sequence. So it's this one, 1, 1, 0.
So we'll say the representative of this array is the lexicographically largest element of the cycle that we see. So
representative of 2, 1, 0 is 1, 1, 0.
Yeah. Okay, so but we're not done with the problem. This is just defining what the representative means. So in this problem, you're given a number n and a number k, and assume you took all arrays and you considered the set of all possible representatives of any sequence of non-negative integers. What you want to do is return the kth lexicographically smallest representative possible. And if there's
among distinct representatives.
Yeah, distinct. So like if you take the set of all representatives, return the kth smallest one. If there's less than k representatives, just like return the empty array.
Yep. Let's see Umnik's screen, because we are most likely to see a submission there right now because he's the only one doing easy problem.
Yeah. And this DP looks on the right track. So
DP of 0 to 1. That's a bit surprising. The indices there, but maybe
it might be like inclusive, exclusive. I'm not too sure.
Yeah. Okay, that would make sense. Maybe he says that the first edge must be from first element to second, and if you say that it's inclusive, exclusive, then yep, I agree. And then there will be some simple transitions here using powers of 2. His array P2 of j minus I minus 1 is exactly what you need to use. You need to multiply dp by that power.
Yeah, and he's making sure the elements are increasing, like aj is bigger than aj minus 1.
He is on the right track. Actually, he is very, very close to solving the problem. If something stops him, it's just some bug, a coincidence. It happens. This looks all right. The leaderboard didn't change much. It's still almost everybody easy plus
Tourist
medium.
might be submitting the 1000 soon. It looks like he's testing the hard problem a lot as well.
Okay. If he submits now, he will have time. He will have points better by more than 100 than Umnik. So he's far ahead. He still has some time.
Yeah. It looks like he's not passing the examples. Yeah.
I
But,
think he didn't return anything.
or he returned 0 when he should have returned an empty array. So I think that's a easier bug to fix, but we'll see if he does find it.
I saw him sorting something.
Yeah.
Is that part of the solution?
Yes, sorting something is part of the solution.
Okay, I thought that it's maybe a brute force, where you get all the possible sequences and you just sort, remove repetitions, and print the cave one. Because in this problem, you consider all the possible starting sequences of length n, no matter the values, and then you get the representative, and in the set of representatives, after removing repetitions, you care about the cave smallest.
Yeah.
Still, there are some bugs here in his code.
Yeah, looks like. Oh, also one thing about the hard is that you are limited in memory. So you only have, so usually the standard memory is like 256 megabytes. But in this problem, you only have 48 megabytes. So you do need to be careful about your memory management in this problem. Okay.
Yep.
Going back to
again.
Umnik.
Still doing the transitions, sure.
Looks like he's just testing locally.
Because of the lack of prefix sums, I think that his code is a bit more annoying to do and then to debug. I like the one with prefix sums better.
Oh, he does pass examples, and he actually does submit soon, I think.
Oh, he submitted. Yeah.
Oh, he did submit. Yeah, so 344. This is behind Andrew a little bit, I think. Or no, actually, this is ahead, right?
But he's behind just if you look at easy, but...
Yeah, so Andrew does need to submit the hard soon if he wants to overtake Nick.
Yep, 600 points right now if Ecknerwall submits. That would put him at 13 and 39. So he can drop to 587. If the white score in Ecknerwall's column, Ecknerwall's row.
587 is pretty soon, so we'll see if he.
It will be
make it.
a minute from now, around that, less than that, maybe.
Yeah, the points don't drop linearly in Topcoder. There is some special formula where it drops faster in the first few minutes, I think, or slower. I'm not too sure exactly, but it's not a linear.
I think it drops slowly in first minutes or seconds, then it goes fast, then again slowly.
Yeah, so I think the reasoning is like it takes some time to read the statement, so you're not really penalized too much for taking longer to read. But then, like once you finish understanding the problem, that's when the points start to drop faster.
Yep. It's a strange solution, but makes sense. It's not that somebody cares that much about this function. You need to do problems fast. The function works.
Yeah. We are hitting that mark right now, so I don't think Andrew's
like maybe 10 more seconds for Andrew to submit.
Okay,
this didn't happen. So Umnik is before Ecknerwall if everything passes and they don't challenge anybody else.
So I think this is Andrew's screen.
Yes, that's Andrew's screen.
I don't know how close he is. It looks like he's just iterating through all bit sets, so that does look like on the right track at least.
Will there be 2 to nth power in complexity?
Yes, so you do iterate through all like 2 to the number of elements.
But do you need to store them in memory? The memory limit is low, like 50 megabytes, right?
Yeah. So I guess like 50 megabytes, so n is up to 26 in the problem. So 2 to the 26 bits is not that much, I think, right?
It would be 60 megabytes if you use single byte per every item. If you store ints, that is 250 megabytes.
Yeah. Or if you just store like the bits, like whether or not it is a representative or not, I think that is much smaller. Or like you can reduce by a factor of like 32 by a bit set or something. So that'll save a lot of space.
What about Tourist? Let's see his screen, and then just let's do a big round through all the participants. Just let's go from the top. Tourist, and then Umnik, Eknerwal again, and 7K plus, Scott, and so on. Umnik is done. Says he doesn't want to fix anything. Well, then if he isn't going to even test that, that's bold.
Yeah, he might just be done with the contest then. We'll see.
Is Tourist still testing, I wonder?
Yeah.
Debugging a lot. Something doesn't work and he's debugging.
Yeah, a lot of print statements and debug statements. So I'm not sure how close he is, but he was testing in the arena earlier.
But it didn't work on some of the...
Yeah, it didn't work on some of the examples, so he's probably just looking a bit more closely at some more test cases.
Neil is testing the 450. Let's see that soon.
Yeah, we'll see if he does get a problem. He has compiled. He actually did submit the medium.
Umnik also declared that he isn't going to challenge anyone. Well, Neil has submitted the 450. And he gets 280 points for that. It isn't either a terrible or a great score, and he needs to do 1000 for sure. If Neil wants to fight for top 3, the prizes and fame, then he needs to do hard.
Yeah, I mean, he does have 20 minutes left, and only Umnik has solved the hard. And I think it took him around 30 minutes or so. Yeah. Petter has compiled the 1000, so he is testing in the arena right now.
What is Scott doing though?
Yes.
Is there something useful in Topcoder website, or is this just view of Arena?
Oh, it looks like Petter has submitted the 1000.
Oh, for 650 points. A lot of things is happening. Petr will not beat Umnik with this score, even though he did hard much faster. But
he's actually within the 50 points. He did resubmit the easy, so that might come back and hurt him. Yeah. But resubmitting the easy does mean he found a bug, so he might have a good challenge case. We'll see if he does find a successful challenge, because he is within 50 points of first place.
Right, let's see other screens. Petr. Petr is done with easy, medium, hard, and should now just test everything. Yeah. He's testing hard. Actually, not testing, reading his code. That's also some kind of testing.
Mm-hmm. Andrew is testing the hard, it looks like.
Okay.
And also Tourist is testing the hard.
Okay.
So both Andrew and Tourist are pretty close, I think. Maybe.
Kalinin looking at extending the status and trying to solve hard. Just like everybody.
Yes.
Tourist has submitted.
Tourist has submitted.
580. That's just 13 points below Umnik.
Yeah, so this looks like it is very close at the top even. Yeah, so we'll see if we see any movement during the challenge phase. Oh, Andrew has also submitted the hard.
That's time to see the leaderboard for sure.
Yes. Let's look at the leaderboard.
Remember, how I said that I hope that people mainly solve easy plus medium, because then people will be close to each other in the total point.
Yes, people are close to each other right now.
Eknerwal needs 55 points to be first.
Yeah.
But for the others, it's just less than 50 away. After coding ends, there will be 5-minute break for participants, during which they can rest or they can work on good counter tests to different algorithms and ideas. And then for like 10 minutes, they can see each other's code and provide a counter test. If they are right about it and they manage to successfully challenge their opponent, they get plus 50 points, and that opponent's code gets 0. And for wrong attempt, you get minus 25. So you can go down the leaderboard because of your bad action.
Yeah. I think 7K plus submit.
7 plus, yeah, 550.
Yeah. And this is also kind of close to like second, third. So he is within one successful challenge of getting to third at least. Yeah, so the challenge phase should be interesting, hopefully, and we might see some movement there.
Like when you see who can beat whom with one successful challenge, if you look at the current top 5, it's exactly like in the 5 piles problem, because every consecutive triple is 50 points away.
Oh yes, that's true.
Maybe next Topcoder Open we can make a problem about that.
Yes, yeah.
7K
This is 7K
plus
plus.
screen.
He's reading his easy
Or just
or
looking
just
at
looking at the
leaderboard.
leaderboard. Yeah,
Maybe doing both.
yeah.
Well, they
Well,
all
making sense.
have 16 more minutes to test their own solution and correct it if they want to, but then they drop a little bit, they will get less point for a resubmit, but after that they cannot correct their code anymore. There will be just that 5-minute intermission and then challenge or hacking phase.
Yeah.
We'll see some other screens. Neil indeed, after doing medium, jumped to hard. Good choice. Now he needs to do hard to fight for top places.
It looks like he doesn't have too much code down, or has like the brute force. Oh wait.
He's still displayed as 980 points out of 1,000, so he just started a few minutes ago. It's unlikely to hard fast that fast.
It's not that much time, so I don't know how much we can see. Oh, yeah, 980. That means he just opened it. Yeah, but I think he wants to at least read the problem, so he might be able to challenge. So.
Oh yeah.
That makes a lot of
sense. You want to know all the problems to be able to challenge anybody. Yegor's screen right now.
Yeah, it looks like he's just looking for patterns right now.
Doing something with bit masks.
Yeah, I mean, maybe we can talk about the solution for the hard, or at least like outline
Then
how to go for it.
Maybe a final look at the leaderboard.
Yeah.
This is Yegor's likely trying with pen and paper something, obviously solving hard. A final look at the leaderboard before we talk a little bit about solution for hard. If every code submitted by participants is correct, because this is not yet tested on the full test suite, if everybody was correct, then Umnik wins, and then Tourist and Petr, they got second and third place. And also regarding the bet,
oh yeah, USA is not doing that well.
versus Europe-Russia thing. Then Umnik, Tourist, Petr, first, second, and third place. That is not looking good for USA.
Yeah, and it doesn't look like there's too much opportunity to move up, even within the for Scott and Neil. Here we see Andrew just walking around. He has solved all the problems, so he's maybe thinking about some test cases. Oh, he's talking to himself.
During the previous semifinals or maybe a lockout tournament, there were some jokes about his cat helping him because his cat is always nearby. So maybe that one is an algorithm mastermind, and Andrew is
So
just
he's talking to the cat,
Yeah.
getting some advice.
They are discussing the good tests for the challenge phase. All
Yeah,
right.
so I guess let's go back to the hard and talk about the solution.
I don't know the solution, so you tell me.
Yeah, I can give a brief outline. Basically the problem is trying to figure out how to classify the representatives. So one thing you can prove, and this took me a very long time, it's not a very easy observation, but one thing you can prove is that eventually every single cycle will devolve into just two numbers, 0 and some positive number. So you can prove that the number of distinct values is always 2, once you reach a cycle. I think proving this, so
is that number always like GCD of initial numbers or not?
I think so, but I don't think it matters exactly what it is, because since you only care about set of representatives, it's always possible to create some set of numbers that you can just start
Is
with
that
sequence.
always number and 0, or can there be?
It's always number and 0,
Okay.
and then they're in some pattern. So I haven't said how to classify these patterns yet, but this claim is easier to prove. You can prove the number of final values, distinct values, is 2. And one of them has to be 0, and one of them is just A. And the way you can prove this, I think, is you look at the min and max of the sequence, and you can show, I think, that the min will tend to 0, and the max will always decrease, or not increase, at least.
Okay, if there is everything is between 9 and 3 right now here, then every difference will be between 0 and 6. Okay, then what if there is 3 and 0? Maybe some other function decreases, like the sum of squares or anything like that. I have no idea. I'm just guessing.
I think the details are a little bit hard, but this is at least the intuition on how to do it. If there is stuff between, once you get the min to 0, the max, I think, can only decrease. It can't increase from now. But even the middle values will eventually become either go to min or max.
Right.
So basically, once you get this idea, the remaining part is not too hard. If you just assume A is 0, A is 1, I mean. So you just iterate through all the bit masks of length n.
Because we care about lexicographically smallest representatives. Can you remind me what is it we're finding?
We take the lexicographically largest element of the cycle, and then we sort them in lexicographic order, and we find the smallest one. So if we know all the bit masks that are valid representatives, then we can just replace the ones with any number, and then we can repeat that to get all representatives.
It will be that we can get this for any A.
Yeah, we can get this
A,
for
but
any A.
For also 0.
Yeah. So if we just solve this problem for ones and zeros, then we can solve the original problem.
Right.
Yeah. So solving the problems for ones and zeros is so originally I thought you had to do something smarter, like finding some pattern for what are valid bit masks. But it turns out you can just write the brute force, I think, and that's sufficient. You need to optimize some constant factors, I think. But for example, given a bit mask, you can compute what bit mask it can reach. So you get some graph with 2 to the n nodes, and each node has 1 outgoing vertex. You can actually reduce the second factor event to just constant time using some bitwise operators, because it's just I think XOR of the number itself shifted.
Yeah. We shift by 1. Okay, I believe you. We shift this number by 1 and we put it here. We XOR, and then indeed every element we XOR with the next one. All right, cool.
Yeah.
But won't that be the space complexity as well?
Yeah, so this is a space complexity. So you can optimize this by using a bit set. So you can store 64 bits per or 32 bits per int. So you only need to store like 226 divided by 32 ints.
But I thought that we need to create something like next for every mask.
So you don't explicitly create this array. You can compute the next for a certain mask in constant time. And the hard part, or like the part that you need to do then, is you can iterate through. You just need to know whether a mask has been seen or not. So it's like 1 or 0, has it been visited?
Okay, so instead of that, we just keep Boolean value visited. And if we do that in a bit set, it will compress all the bits.
Yeah.
So
you use this array to find all the cycles, and you can, like, basically the way you do that is just follow the next pointers until you visit something that you've seen. And once you do that, you can like iterate through the cycle again to find the max element. And then it turns out the number of representatives is pretty small. I think it's on the order of like 100K or so, or 600K in the worst case. So you can just store all the representatives in a normal list, sort them, and then.
I wonder about the reasoning to decrease this space required. Like, is there something easier possible because it's the memory is smaller than usual, or was it just about maybe otherwise some programs would be on the boundary? Sometimes it is an issue, but if you need exactly 250 megabytes, and if memory limit was that, then some people would pass and some would not. Maybe organizers try to avoid that.
I think, yeah, I don't know the exact reasoning for why the memory is limited, but I think like if it was like a normal memory, then like it might be possible to squeeze like the like storing all the pointers, right? Or like it seems like barely enough. You might need to compress a little bit. Yeah, there are some more observations you can make to reduce the amount of space, but I don't think they're needed, or at least like the time complexity seems pretty good, or like it is pretty fast. So like for this problem, you are also given a little bit more time than usual. You're given 6 seconds instead of the normal 2. So like you have a lot of time to like iterate through all these bit masks.
I'm surprised by how doable this end of a solution seems. I expected something very hard, but maybe just I was too scared of a problem. Sometimes when you look at statement, you from that can judge if the problem is hard or not.
Yeah,
I thought that it's extremely hard.
yeah, that was my first impression as well. It took me some time to figure out the first observation. But I think the samples do help a little bit. Like the samples do include like a slightly bigger case with like n equals 7, and you can see there's only 2 distinct values in the answer, so maybe you can guess from there what you need. But yeah, I mean the remaining part, I did also think you needed something trickier, but seems like pretty doable if you just like write the brute force find cycles.
I wonder how many people will actually be stuck at this last part, because we saw people trying to find patterns for binary masks, right? Does it mean that every such a person didn't think that, oh, you can just use a Boolean array?
Yeah, I mean, we did see tourists printing like the bit masks, and I think we saw Umnik printing bit masks too originally. So I think the reason why you would want to do that is like you're not sure how many representatives there can be. Because in the worst case, if there are up to like 2 to the n representatives, you can't store them all in memory. So that might be one reason why they were looking for patterns. But I think the way you can get around that is you can just actually generate all the representatives locally on your machine, and you can see that it's not very big. So once you notice that.
There are just 26 different inputs being value n. For each of them, you investigate what's the number of representatives. And K doesn't affect that, so you don't care at this.
Yeah, you don't really care about K. So I think if you have this observation, you just like write the solution, and then you just count the number of representatives, you'll see that's small, and then it's fine.
Scott is printing some bit masks. He right now has the 7th place, so 3rd from the end.
Yeah.
And he's doing hard. Finding cycle, having an array for seen vertices, that might be the intended solution.
Yeah. If he's printing bitmaps, it might mean he's close. I mean, the next step is just like to like see how many distinct representatives there are. There are only about 4 minutes left, so I'm not sure if you'll be able to finish in time. You might see a last-minute submission.
Might be close. Yegor is then on the 8th place out of 9 participants. We can take a look at his screen as well. And then obviously Neil doesn't have a
we can see
convenient
what Neil is
situation
saying.
because he would need to solve hard very fast.
Yeah. Yegor is. It looks like he has the right idea. He has the set of all representatives in R, it looks like. So it looks like he's pretty close.
I'm seeing bitmask operations, bitwise operations here, but that
Yes.
doesn't tell me too much. What is times? Do you see that k divided by r dot size in line 85?
Oh, yes. Yeah, I mean, so basically, once you have the set of all bit masks, you can just repeat that sequence to get like the set of all.
Oh, yeah, that's the last step because k is huge. K isn't limited by the number of representatives for
So you need to
A
figure out the value of A. So like it's like k divided by r dot size, and then like which bit mask you choose is like k mod r dot size.
So times will just tell you the value of A. Value of A will be like times plus 1 in this case. All right. 2 minutes left.
Yeah, I mean, it looks like this logic is correct, so you might just be testing, making sure it runs in time for like n equals 26.
We'll take a quick look at Neil's screen, and then for the last minute, let's just look at the leaderboard, unless there are other requests. There, 1 minute and 45 seconds till the end.
Okay, I guess we can move to the leaderboard. Let's see how that's going.
Scott, Yeager, and Neil for sure working hard, but only 90 seconds left. 90 seconds isn't that little. Like every experienced competitor solved some problems in the last seconds.
Yes, it is very possible to solve within the last few seconds in submitting them.
And it's the most satisfying feeling.
Especially if it's correct. You have to hope you didn't make a stupid bug because it's sometimes easy to miss some things in the last minute.
Will actually that change the leaderboard in any way? If Scott, assuming nothing fails, I think Scott would jump just by 1 place. Oh, he's printing the number of representatives. He's running that for 26.
Oh, yes. It looks very slow, though. But, yeah, it might be too little, too late, though.
10,000? That's just very little.
Yeah, I think that's the wrong number. I got it around, like, 500,000. So I'm not sure. He might be printing the time, maybe.
Half a minute left.
Yeah, it doesn't look like he's close to submitting, so we might not see it. And we only have a few seconds left.
Just he gave up looking at the leaderboard. Then they have 5 minutes to create some counter tests. And if, from Scott's perspective, he has a chance to fight for top 3 only if one of the problems is really tricky and a lot of people maybe missed some case. Mm-hmm. So there is hope for him. And if that's the case, then he should fight for challenges. Right now, it seems that plus 50 will not affect his place. But he should hope for the case that tests are weak. The example tests.
The samples are weak. Yeah. If the sample tests are weak, there are a lot of challenge opportunities. Okay, so it looks like it ended. We didn't get new submissions. So this is the leaderboard for now. We'll now enter challenge phase after 4 minutes of the break, where people can read each other's code and try to find bugs. For each successful challenge, you can get 50 points. For each unsuccessful challenge, you'll lose 25. The top of the leaderboard is pretty close, so we can see a lot of movement up there.
Umnik is winning, but Tourist and Petr are just both 1 challenge away. Eknerwal and 7K Plus, each of them, they will gain 2 places by challenging. Eknerwal would push tourist from second to third place, 7K would be just above Petr, and 7K with 2 challenges would get first place. I hope for something exciting to happen here.
Yeah, I hope there are a lot of interesting challenges. I don't remember the test cases too well, or the sample test cases at least. So I don't know if there's any obvious holes that are missing.
So we can look at some screens. Maybe we'll notice somebody indeed working on tests, or still testing their own solution. But most of participants had already half an hour for that, so maybe now they are just chilling.
Yeah, a lot of people did finish early, so they might have already tested a lot before then.
This is Neil's screen.
Yeah, it looks like he wrote the brute force. I'm not too sure, I guess. He might be trying to solve or like look at patterns for the 1000 still. Because it is still, like, it's unlikely he'll move too much though, unless like the easy or hard turns out to have some really tricky edge case that was missed. But he could still try to take challenges away from other people.
Andrew is testing something in the arena. It seems to be a max test.
Yeah,
but also
it looks like he might be trying to force some worst case behavior that's actually n cubed, maybe, if somebody did something incorrectly.
All right, 2 minutes left. Chat can tell us whose screen we should look at the beginning of the challenge phase. For sure, it should be somebody in top 3, Umnik, Tourist, or Petr. And Umnik already said that he isn't going to challenge.
Yeah, I think he already said he's done with the competition. So it's mainly Tourist or Petr who can move up.
A friend of mine once, after solving 4 problems out of 5 in a competition, and it was like half the competition, he was winning. He didn't like the last problem, and he just quit. He went for a walk. For the next 2 hours, he was out, and it was enough. Nobody solved the last problem indeed, so he won. But I wouldn't say that's the best strategy. So also, it might hurt Umnik that he isn't going to challenge, because not only plus 50 for Umnik would make him safe from Tourist and Petr, but maybe otherwise the challenge will be taken by Tourist or Petr. Umnik should prioritize now not allowing Tourist and Petr to gain points.
Yeah, that's true. So we're about a minute away from the challenge phase starting. Yeah, we were looking at Tourist screen right now, and he was like looking at some of the hard cases. It looks like.
Exactly the second when the challenge phase starts, then participants get access to each other's codes. They can open something, they read the code, just scrolling through. And in the first seconds, it's mainly looking for a particular mistake, like too small array.
Yeah.
You can, in 1 minute, actually open code from every participant, quickly look at the value of max n if they use global arrays. And if it's too small, make a hack, make a challenge. If not, move to another one. Then for the next 10 minutes, it will be more calm, like really looking for mistakes, trying to understand codes.
Yeah, I don't think we'll see any blind challenges because since everybody is so close up the top, even minus 25 can change a lot. So people will want to be fairly confident in their challenges, I think, before making one. It actually looks like Scott actually unsuccessfully challenged Colin's 1000.
Wait, already?
Yeah.
Oh, all right. Because maybe Tourist screen just lags a little bit.
Yeah.
There's some delay there.
Yeah, it looks like Scott is doing some blind challenges. Yeah, he did Colin and Umnik's 1000. Probably just a max test. He did those very fast, so he's hoping if the 1000 is very hard to solve, he can get those cases very early.
Yep.
But
then let's switch to his screen, to Scott Wu's screen, if possible. But yeah, he should assume that some problem has weak example tests, and then he will still fight for top 3. So because of that, he should do what he's doing.
Yeah. So notably, the 1000 does not have a max test in this sample, but it is very easy to test the max test by yourself.
Did Scott have 6th place before? Sorry, 7th place before that?
Yeah,
I think
he did
dropped
have
below
7th
middle.
place before, but he made 2 unsuccessful challenges. So this is Scott's screen. It looks like he is reading, or he's still looking at hearts. Yeah, I mean, the thing is, like, maybe if he didn't solve the problem, he might think that storing all the masks is too slow. So that's why he made those challenges first. But given that those pass the max tests, like, I think those two can be pretty confident those are correct, at least, or that approach is correct.
For now, no more challenges. 2 minutes passed, 8 to go. And after the 8 minutes, that's still not the final leaderboard, because then the real set of tests is run. Hundreds of tests created by author of each problem to really check the time complexity, just the running time, memory usage, how effective your program is, and if it's correct. Only then we will get the final leaderboard and we will know the winner. Tourist look is going through hearts still.
Or it looks like he was looking. Oh, this is Petter's. Petter's looking out towards 1000.
Talking about the strategy for a moment, maybe. When you are second, so Tourist is now second just below Umnik, right?
Mm-hmm.
And it actually doesn't mean that Tourist should try to challenge Umnik's codes. Most of the time, real tests run at the end are strong. So from Tourist's perspective, if Umnik has something wrong, Tourist will win with him anyway. Umnik will drop to the bottom of the leaderboard. Mm-hmm. So for Tourist, he should try to get plus 50 by challenging somebody else, because Umnik isn't anyway a strong opponent for him if Umnik has something wrong. Or Tourist also should worry about Petr and Eknerwal doing the plus 25. So maybe Tourist actually should prioritize Petr or Eknerwal. Actually, no, I don't think that's very smart. Maybe he should just prioritize people other than those from the top.
Yeah, because if those fail, then it doesn't matter if you got the challenge anyways, because they would have dropped.
He should go from the maybe just bottom of the leaderboard. That's a fine heuristic.
Mm-hmm. Yeah, we see Tourist's screen right now, and he's looking at easy problems. I'm not too sure how many tricky cases there are for the easy. We did know that Petr did resubmit, so there might be something that you can miss. Yeah, I'm not too sure though.
Kevin Sun in the chat said that he hoped for Scott to help to Eknerwal, because actually you don't need to pass example tests to submit your solution. Even if you have nothing, if your program just says return 0 and that's it, you can submit that. Mm-hmm. And Scott or Neil, he got another minus 25 now. Scott or Neil, maybe to help to Eknerwal, to help him win, they could create some fake submissions. Theoretically, it isn't forbidden by the rules. I don't know how fair play it would be treated as.
Yeah, if you make an agreement beforehand. I think that is I don't think it's explicitly against rules. Oh, Scott actually unsuccessfully challenged Eknerwal. It looks like he's just going through the 1000s and testing all of them on the max cases.
What if they didn't agree? What if they didn't agree in advance? Is it fair that, let's say, Scott wants to just decrease the variance in the leaderboard? He wants to see the word burn or whatever, and just imagine that in last seconds actually he rewrites each of his codes and he submits 3 blank programs.
Oh yeah.
What this would do is then it would be a contest of speed, who hacks him fastest.
Yeah, or who just stumbles upon his submissions. It actually looks like Scott did make a challenge to almost everybody's 1000, except for Tourist. So he's running like a sys test for them, kind of, to make them more confident in their solutions. Yeah, he's probably testing on the max case. We can't see what exact case he's challenging on just yet, but yeah, it looks like he ran through almost everybody except for Tourist, I think. Yes, I think we're switching over to Scott's screen.
Is that Scott? Because it doesn't seem like he's testing each everybody's
Looks like
code.
he stopped, or he might have done everything. Yeah, I mean he did challenge all the 1000s almost. So those, if he did test on the max case, I think those are reasonably more likely to pass then.
But he didn't try to challenge Tourist, right? So
yeah, he did not challenge Tourist, so maybe Tourist will fail.
Yeah. Then Tourist's code is now a bit more dangerous, more risky, more likely to not pass the sys tests because it isn't checked by Scott.
It hasn't been tested by Scott. Yeah, that's true.
I wonder if Umnik will watch the results unraveling, or maybe he's just watching something in TV, playing games.
Yeah, he's watching Brooklyn Nine-Nine, as he mentioned in his bio.
Tourist is just calmly reading notes. 2 minutes are left till the end, and the last seconds might be interesting too. I would say that, well, Tourist, Petr and Ekner, they have second, third, and fourth place, and even if they don't see anything wrong with codes from other people, they can challenge because, well, it isn't forbidden. They risk, I think each of them risks dropping down by one place because you get minus 25. Maybe it isn't the case for Tourist. Oh yeah, let's see the leaderboard for that. I think that Tourist can safely do that because Tourist minus 25 is still above Petr.
Is it? Yes, it is still.
The difference is like 35 actually. 0.5.
Yeah. So if he does do one challenge, he has one opportunity. So we might see one at the last minute.
Yep.
I think in this finals, I forget who gets the prizes. It's like top 3, right?
Most of the time it's top 3, and you say that you got gold, silver, and bronze. Then for sure, let's see his screen, Tourist screen for the last seconds. For anybody else, if they challenge to try to get Petr, maybe also will try that, but then he, in the worst case, he drops from third to actually fifth place by 2 places. So from third, it's a kind of gamble, maybe 10% that he gets first and 90% that he gets fifth. Then the third place seems better.
Yeah, third place seems like the safer choice to stick with. Yeah, we're rounding at about 30 seconds left.
Let's see Tourist screen for this last minute. That's around 20 to 30 seconds left. Yeah, he's clicking the challenge. All right.
He's just testing a max
made
case.
His mind.
Testing 7K plus.
Unsuccessful.
Okay. Unsuccessful. Well, I mean, it doesn't change his place as we mentioned, and the challenge phase did end, so we don't see any further movement.
But he did well. It's not really when you make decisions in any kind of game, and actually the challenge phase is also some kind of game. It's not only the wait.
This might have just been a slow challenge that was processed later.
All right.
Petr did challenge Neil.
Petr took his 10% to get first,
10% chance,
90% to be fifth. Or maybe he saw an issue. Maybe he thought that there is a chance. Maybe he estimated this not as 10%, but as 90% for the first place, or maybe 50-50. Then, of course, it wasn't stupid. But I was saying that it's not the final result that matters in any kind of game, but your strategy, your decision. If you can explain your decision rationally, then it was a good decision.
Yeah, and as we mentioned, like Petter did have a very small chance of getting first if he did get the successful challenge. So it was worth the risk maybe for him because he might just want the title again.
No, people don't usually remember who got the third place. They remember the champion. In Topcoder statistics every year, when we introduce every participant, we don't say how many times they got top three.
Yeah. Petter has already like 4 wins, I think.
Yeah,
right? 4 or 5
he
wins.
is the four-time world
needs
champion.
the
So
title
maybe
again.
thanks to those taking the risk every time and risking the 5th place.
Yeah.
If he maximized his chances for the first place, he did correct. He needed to challenge.
Yeah.
But then Eknerwal should be happy about it because he got the 3rd place.
Yeah, that's true. He did move up without having to do anything. So we are rating on system tests now, and we'll see how the competitors do against the main test. And after, I think, are we going to do like interviews with some of the contestants?
I don't think we have interviews today.
Okay. But we'll see the final results at some point later in the stream.
Yep. We have 1 more minute here. If we, I don't know if you can now switch to the leaderboard. Still, it's temporary leaderboard. There will be sys tests, and then only then we'll know the final ones.
Yeah.
But right now, Umnik, Tourist, and Eknerwal, they form the top 3. And Petr, sadly, he dropped to 5th place, but it was for sure a well thought through decision, and it wasn't stupid for sure. We might have a new champion. I don't think that Umnik ever lost.
Yeah, that's true. Yeah, we might see a new TCO champion. Yeah, so I think we'll switch to Nick now.
All right. Thank you guys for watching. See you, Halloween.
Yeah.
All right, what a match. We had a lot of competitors solving all 3 problems. It got really tight up there at the top. Nick is currently leading, followed by, I believe, Tourist, Eknerwal, 7K Plus, Piotr, and so on. That is the top half of the leaderboard, and we'll see tomorrow during our awards who actually goes home with the gold. Do we have a new champion? Does Tourist reclaim and three-peat? Does Piotr come from behind somehow? We'll see tomorrow. So that'll do it for us today. We start at 9 a.m. Topcoder time. That's UTC -5. We will see you bright and early tomorrow morning. Thank you so much to Errichto and Lewin, and